Okay, so we're given question 9 here. NM, ND, and DM are tangents to the circle. JH is parallel to GD and angle H3 is given as X. So you look for keywords here. If we look at the word tangent, I like to look for tan-chord theorems as soon as I see the word tangents, especially when I don't have a center. If I had a center, I would look for a radius perpendicular to tangent or diameter perpendicular to tangent, but also I would look for tan-chord theorem. So I can see DM is a tangent there. I can see immediately that H3 would equal to angle J. My tangent being DM, my chord being HE, so tan-chord theorem, HE makes J at the circumference, so H3 would equal to J. If I look at the other tangent, ND, I can see angle E1 would equal to angle J because your tangent is ND, your chord is EH, and EH makes up J at the circumference, so E1 would equal to J there. There are others, but they aren't marked, so let's go on. The word parallel, JH parallel to GD. As soon as I see parallel, I look for alternate angles, corresponding angles, and co-interior angles. So if I look for any alternate angles there, I can see that H1 will be equal to G2. That's alternate angles. I can see that angle J and angle G3 will be equal because those are corresponding angles. Okay, and we'll continue for now. Let's see. 9.1, prove that angle G3 is equal to X. Okay, so we start with angle H3 because that's given to us as X. So we'll say that angle H3 is equal to angle J is equal to X, and that's because of the tan-chord theorem. I explained that earlier. Then we can say angle J is equal to angle G3 is equal to X. That would be corresponding angles because JH is parallel to GD. So angle J will equal to angle G3 equals X, which means that G3 is equal to X. Okay, 9.2, prove that DEGH is a cyclic quad. So DEGH, that's the purple quadrilateral there. We need to prove that that's a cyclic quad. When you're proving something is a cyclic quad, you need to prove that the exterior angle of the cyclic quad is equal to the interior opposite angle, or you can prove that the opposite angles of a cyclic quad are supplementary, or you can prove that angles in the same segment are equal. So in this purple diagram here, the cross in the middle tempts me to look for angles in the same segment. And if I look for angles in the same segment, I can see that angle H3 is actually equal to angle G3. We know that angle H3 is X, that was given to us, but we just proved that angle G3 is also X. So we can say now that angle H3 is equal to angle G3 is equal to X. That's proved, and that implies that DEGH is a cyclic quadrilateral, and our reason there is the converse of angles in the same segment. 9.3, we need to prove that DG bisects EGH. So DG is a straight line, and that needs to bisect EGH. That means that angle G3 must equal to angle G2. That's what they want there. So angle G3 we know is X. If we can prove that angle G2 is equal to X, then we've proved it. Then we've proved that DG bisects EGH. So let's start with angle E1. Angle E1 is equal to angle J. That's equal to X. Tan-chord theorem, if you can see it. Your tangent is ND. Your chord is EH. EH subtends J at the circumference, which makes angle E1 equal to angle J because of tan-chord theorem. Then we say angle G2 is equal to E1. That's equal to X, and this is because of angles in the same segment. We just proved that DEGH is a cyclic quad. So it means that angle G2 will be the same as angle E1 because of angles in the same segment. So that means that G2 will equal to X. we say that G3 is equal to x proved before. Therefore, or that implies that angle G2 is equal to angle G3, which is equal to x, and that means that DG bisects EGH. 9.4, prove that DM is a tangent to a circle passing through F, G, and H. There we go. There's your circle passing through F, G, and H. We need to prove that DM is a tangent there. So we start by saying angle H3 is equal to x. That's given to us. Now, if you want to prove that something is a tangent, the easiest thing to look for is tan chord theorem. So if I'm looking for tan chord theorem here, my tangent's DM, my chord is HF in this blue circle. So HF will subtend G2 at the circumference of the blue circle. H3 is equal to x, that's given. G2 is equal to x because we proved that. So we can say therefore DM is a tangent because that's a converse of tan chord theorem, H3 and G2. 9.5, H is a point in a circle, in the circle such that points H, X, G, E are concyclic. Explain why H, X, E, and D are also concyclic. So to prove this, we say that H, X, G, and E are concyclic, D, E, G, and H are concyclic. That means that H, X, E, and D are also concyclic.